When I first learned about the project, it was a very exciting time because I was offered this project with this big goal of, well, you come here for your PhD and your goal is to set the world record for the highest rotational speed ever achieved by an electric machine. My name is Marcel Schuck. I'm currently a PhD student at the Power Electronic Systems Laboratory. What we asked ourselves was, what are actually the rotational speeds that we can achieve ultimately, and what is the highest rotational speed that we can achieve with an electric motor. So I thought, well, there's a huge potential, there's a great opportunity, but of course on the other hand there is a huge possibility also to fail, and I mean that's one of the biggest fears that you have when taking on such a project. Looking back into the literature, it dates back to the 1920s when a group at the University of Virginia, particularly one researcher, Jesse Beams, started out developing magnetic bearings. They suspended the rotors magnetically inside a vacuum. By the end of the 1940s, they had reached rotational speeds that ranged into 30 million RPM. And it had not been exceeded significantly until the 2000s, basically. So this made it very exciting for us to start our work on such a historical basis. What you can see, it's quite a big machine for such a small rotor, and we can quickly go over the details. This is the axial bearing coil that's used to levitate the rotor. We have 4 drive coils. In these drive coils we apply the drive current for the rotating magnetic field, and then also the bearing current for the suspension and the stabilization of the rotor in the radial direction. The first time we tested this active radial bearing, it was a really great experience. We had everything up and running and all the colleagues would gather around the machine, and we knew from before that the slightest disturbance would really cause the rotor to become unstable. And of course all the colleagues started to shake the machine, and you could really see how it would tilt and oscillate. And the rotor was really stable in the center, and already in one of the first tries after we had this technology we achieved rotational speeds of 12 million RPM, and after that it was more or less a matter of scaling down the rotor and stabilizing smaller and smaller rotors. So we have reached this rotational speed of slightly above 40 million rotations per minute, and now we can go into 2 directions. One thing is to push this speed even further. That means even shrinking the setup down further and further, making things smaller, making the rotor smaller, reaching higher rotational speeds, but also looking into applications of future drive systems. So transferring the control structures, transferring part of the construction of the machine to something that can actually benefit society as a whole. That is really a great opportunity, and I'm looking forward to seeing some of these principles applied actually in practical systems.